Hello everyone. So in this video I'm going to show you how to make the game of Snake. Here's an example, and it starts off with two pieces, uh, two cells I guess you call it. Then every time you eat your food you grow by one cell, and this is I'm going to show you the code. This is definitely very versatile in that you can make this grid any size you want, make the cells the size you want. You may notice up in the upper left hand corner there's actually a score that basically is how many times you eat the food. I'm going to go off the board to kind of die, just to I'll leave that up in the background, but let me go over the code here. This is in Java. I've actually done this in Python. I've done this with PyGame in Python, and I've done this in processing. So if those platforms interest you, let me know. I'd be glad to make a video of that. Using graphics interface and JPanel really to get this done, and there's a series of arrays and ArrayLists that keep track of everything for us. And so let me go over. This is the size of the board. Again, like I can just change these numbers, and we could tweak the size of the board there, and also the block size. That's 30 pixels by 30 pixels. This is basically our grid. This is represents each spot, each cell on the board. So that's a multi-dimensional array. Then here I have some array lists that basically keep track of the information about the snake, each cell of the snake. This is actually keeps track of that. This is of type snake cell, which I'll show you what that is in a minute. And then these are, I'll explain these, but these are temporary integer array lists. I call them temp x, temp y, and temp d for the x and y coordinates of each of the cells in the snake, and the direction as well. So the snake cell is very simple. It literally is just a class that keeps track of the x and y coordinates of each cell in the snake, and the direction that the snake is traveling. So that's that. That's kind of the basic start. Then I create two. I start the game off with two. So S1 and S2 are two different snake cells. I just kind of arbitrarily picked around the middle of the board to place these. And then I also have our food. That was the red dot on there. I'll show you in the constructor. I actually create a random location for that. And we want to keep track of the size of the length of the snake. So that's what that's doing there. Then I add that information. Like I said, this snake array, actually array list, it has each location, and it keeps the x and y coordinates and the direction. And then I have these temporary variables, temporary array lists, that also keep track of the x and y coordinates. So in a moment I'll show you why I need it. It might seem kind of odd that I have that, but there's a good reason for it. So here's where we get our x and y coordinates, random. I have a function that produces a random number between the numbers that you send it, and so that's the size of our grid. And then I just update remember our spots array list is a multi-dimensional array that represents each spot in the on that grid, and if there's a 3, that means that's where the food is, and so that's what I'm doing there. And then this is our key listener part, and basically I'm using the left, right, down, and up arrows, and I have the direction change based on which of those arrows was clicked, and I just kind of arbitrarily gave them these integers to represent. 1's up, 2's down, 3's left, 4 is right. This little if here is just so you don't go back on yourself, right? So if I'm traveling to the right and I click this left arrow, I'm not going to let us change direction, because that would be bad. You'd go back onto yourself. So I don't let you do that. I could have made it so that you lose the game if that happens, but I just thought usually you probably hit that as a mistake, and so I just don't let you go back onto yourself, and so that's what's happening there. This is probably the most important function, the move function. We go through the whole snake array list and look at each spot. As I had said before, I remember the coordinates of each of the cells. So basically the X and Y coordinate in the direction. I have that saved in here. This is a variable that I had started out at 0, and so I just set that in here, and then you'll see in a second what I'm going to do with that. And the first time through this for loop, that's going to be the head, right? Because I put it in that order. The first spot in our array list is our head, and I have it so that we grab all that information about the head, and I change the direction should reflect whatever we clicked up here, and so I'm just setting that right here, okay? And then I'm going to change the cell based on that direction. So if 1 is up, so if we're going up, we would change the y-axis by 1, and we actually subtract it because the top left-hand corner of the board is 0, 0 for the y and x, and so we would subtract it, and then we just do accordingly here. If I press 2, we're going down, so we would add to the y-axis, then the left and right as well, and then we just save that information back to our array list so that we keep track of that. And then so I change these locations. I need to check to make sure that this new location that we move to is actually a valid place that we can move to. If we go out of bounds, if we go off the board, then it's game over. And so that's what the else part of this. And I actually just break right out of this for loop. If not, we continue down in our loop, and we look to see right here. We look to see if we're at the end of the snake, the tail, because if you look at our snake, this is the tail. What the head went out of bounds here. This is the tail. Every time it moves, the space behind it needs to be erased and is colored white. And so 0, and I'll show you in a minute, it represents white on our board. And so that's why that's there. Then we go through, and so this is where we actually use those temp array lists, temp Y, temp X, and temp D, because it's very important. We saved the information. So basically I'm looking at the count variable and I'm going 1 back, because that's how we move. Like this spot here, when we move, is going to get the information in the spot in front of it. So that's where it's going to move to, right? So every time we move, each of these cells is going to move to the spot wherever the previous location of the spot in front of it was. And so that's why we need to remember that information about where those cells were, because that's where we assign our current cell that we're examining. We look to be, hey, what was the one right before it? So -1. And we give it a new location and we save that back. And then lastly, we just update our spot array, our multi-dimensional array. 2 represents blue. So that's right here. And so that's why we're giving it blue. And then we're just updating my count variable so that we can come back and do everything again inside this for loop until we get to the end of the snake array. And yeah, that's it. The only last thing I have in here is I just once again check to make sure if we can move before I call the eat function, because the eat function, examines the whole board, and if we're out of bounds, I'd rather be the one that determines the game is over instead of having an error end the game for us, an actual runtime error. So yeah, that's what's going on there. Here's the random method that I was talking about that produces a random number between A and B. And here's our eat function, which basically just looks to see, hey, is the head of the snake, spot 0, right? Is it equal? Is it on the cell where our food X and Y is? Because if so, then we're going to get a new random number for our X and Y, for our food X and Y, update our spots array, and then we actually add so based on the direction we are moving, we add a new cell to our snake's going to grow. And our new cell has to be right behind the tail. And so that's why I'm looking at snake length -1, because the tail is always at snake length -1. And if the direction was going up, then we need to put this right below it on the y-axis. And so that's why it's cy +1. And then, the same kind of logic for each of the different directions for how we place the snake new cell on the board. And then, all we do is also make sure we update our temp variable to hold that information as well about our new tail. And that's it. That's the main thing. This can move is pretty easy. It's just looking to make sure we don't go out of bounds on the height or the width, or and we don't want to be less than 0 in the row and the column either. And then in our paint method, again, all we do is go through our spots array and see where we have zeros. That's where we're going to paint white. If we have a 2, that's where our snake is, so we paint blue rectangles. And if we have a 3, that's where our food is, and we paint a block there. And then this XX and YY is just for the spacing to create our grid. And then I just give us a score using a drawstring. And that's it. All that's down here is this runs the game. This is a while loop that keeps on running. And we just keep calling the move method and repainting our board. And this here, you can change this if you want the game to run faster or slower. And actually, I was going to make this a variable that's on my to-do list to do with this. Make it a variable that will kind of get, the lower this number gets, the faster the faster the game moves. And so I was going to have it like incrementally throughout the game get a little faster, so it became more challenging. I actually have up at the top here my kind of to-do to make it go faster, detect if the snake hits itself. I don't have that working. That should be pretty easy though. I just checked it, kind of like I check for the food. I check to see if I'll make a function that'll check to see if we have encountered, if the head has encountered another part of its own body. And that should be easy enough by looking to see if it's a part of the snake array list. And then when I spawn a new food block, I need to make sure it's spawned in a location where the snake does not exist. At this point in time, that is not checked for. Not a big deal. If it does, it would just eat it, expand the snake, and spawn it somewhere else again real quick. So it's not the end of the world. And so let me know if you want more to this. If you think this is cool, if you want me to show you how to do this in another language. I hope you enjoyed it though. Thanks.